Okay, so this is the next session on the KubeVirt Summit. Nashun and Oren are here to tell us about the Hyperconverged Cluster Operator, a way to deploy multiple KubeVirt components in an opinionated way, but they will tell you a lot more about it. So all yours. Thank you.
So, hello everyone, and thank you for joining. I'm Nashon from Red Hat. I'm working on the KubeVirt installation and upgrade team. And here with me is Oren. Please present yourself.
Hello, I'm Oren Cohen, a software engineer in KubeVirt's install, upgrade, and operator team in Red Hat.
Okay. So, we will talk in this session about the HCO, the Hyperconverged Cluster Operator. Why do we need it? What it does, what we are planning for the future, and hopefully we'll have some time for questions and answers. So let's start. So why HCO? In order to have a fully functional virtualization system, we want several components. So we want to have a compute subsystem and storage and networking, and we want to have a way to import VMs from other places, and we want templating. And we have subsystems like that in KubeVirt. We have the KubeVirt for compute and CDI for storage and so on. But deploying and configure such a complex system may be a bit challenging, and this is where HCO come in for help. So the goal of the HCO is to provide the right set of components in order to deploy the fully functional virtualization system in Kubernetes, and to be a single entry point for multiple operators where a user can deploy and configure them in a single object. HCO provide opinionated deployment for KubeVirt and all the rest of the components. And we want to make these processes, the deployment, the configuration, the upgrade, as much easy as possible, and to make it easy to monitor and configure and to install and to upgrade and all the boring stuff that should be automatically done as far as possible. We have some kind of relationship with OLM, but we, even though HCO control several components, it's like a meta component, meta operand. It doesn't replace OLM. OLM still working, and OLM still control the life cycle of the deployments and the operators, and HCO controls the CR, the configuration, and the monitoring, and so on. So let's talk about the HCO responsibility, what it does. First of all, it makes sure that all the components are deployed with the matching versions in order to avoid the dependency conflicts and problems with this kind. HCO packaging shipped with a single cluster service version file, a CSV, that contain the configuration, how to deploy all the operators, the CRDs, and everything with the right versions. And the same is done for upgrade, actually, because we want to upgrade the whole system in one transition. Again, to avoid conflicts and to be able to ship new features that are cross system and things like that. We talked about OLM before. The OLM integration, I mean, HCO is the integration point for the system. And for example, it reports the status of the system by aggregating the conditions of all the rest of the components and report the cumulative status to OLM. And the rest of it, I think we talked about. By the way, we don't force to work with OLM. If you don't want to, HCO can work without OLM too, and we are doing it in test all the time. We want to have HCO to be the single point for configuration for the whole system. Now, this is still in progress, and we will talk about it later in some more details. But the idea is that the user will have to deal only with one custom resource. She will deploy only the hyperconverged custom resource and configure it, and HCO will take it from there and propagate to all the other components as needed. So how is it working? So we have here the end user, in our case, the system administrator that want to deploy virtualization on Kubernetes. So they will go to the marketplace, the operator hub, and will deploy the KubeVirt product to the system. Within the shipping of this system, we have the catalog and the CSV for the specific versions, and the user will choose the version and deploy it, and OLM will take it, create a CSV object from it, and will, according to the CSV, will create all the CRDs and operators, and will make sure that the operators are up and running. And then, again, the system administrator will create one and only hyperconverged custom resource here. And from that moment, the HCO operator will take control and will create all the rest of the CRs and monitor them, and the system can start working. And now we will have a short demo from Oren. So Oren, please take control. Oren, we can't hear you.
Hello everyone, and thank you for joining. In this demo, I'm going to show you how KubeVirt and all of its supporting operators, such as CDI for storage, CNA for network, and so on, all can be easily deployed, monitored, and maintained by the Hyperconverged Cluster Operator on OKD cluster or OpenShift Container Platform cluster. HCO is not yet available in Operator Hub by default, but will be soon be there. Until then, we can create a custom catalog source by navigating to cluster settings, global configuration, Operator Hub, sources, and we create a new catalog source. Let's call it HCO catalog source, and the image URL of the container image is this. We are publishing the most recent index image here, and we're creating it. Once we create the catalog source, a pod is being created on OpenShift Marketplace, and this processing the index image and make the package of the operator available at Operator Hub. Now we can navigate to Operator Hub and search for KubeVirt keyword. We can see it here. We can see general information about the operator and description. Clicking on the install button, we choose the most recent update channel, which will soon be changed to stable. The operator is installed on a specific namespace on the cluster, which is KubeVirt Hyperconverged. This operator is singleton, meaning it can be only installed once per cluster because it's watching all the virtualization resources within the cluster. We click on install. Now the first stage of the installation begins. The resources are being deployed by OLM. We can see, we can navigate to KubeVirt Hyperconverged namespace, and we can see our operator is installing. And the resources that it's installed are listed in the install plan objects under component. This is what's going to be installed by our HCO package. These are mostly CRDs and service accounts and role bindings, and also the CSV object, which is a spatial object containing all the deployments and other resources that was defined to be deployed. These are the initial deployments, mainly operator pods that are in charge of watching their CRs and acting accordingly. Once we see that all pods in stage 1 have been deployed and the status is succeeded, we can proceed to creating the HCO custom resource. And there is the form view or the YAML view. We can set some feature gates. These are the default values. And we can click on create. Once we click on create, the custom resource is being populated with conditions telling what is going in the cluster. Currently, SSP is progressing. And we can see that a bunch of additional pods have been created, which are deployments and daemon sets. HCO created the custom resource for all the underlying component, such as KubeVirt, CDI, network add-on config, SSP, and so on. You can see that all were created within a minute ago. So since we created the custom resource. So when all the pods are going to be ready, the HCO operator will be ready as well, and it will signal installation is completed. I'm pausing and waiting. Okay, now the HCO is going to be ready, and the installation is succeeded, as we can see here. If any disruption will made to the cluster and for a component, it will be reflected here in the conditions. And now that the installation is completed, we can move to the virtualization page, which is shown after the installation, and create a new virtual machine using the UI. And this is all I wanted to show. Thank you very much.
Thank you, Orion.
Okay, I just wanted to add that what you see is it's just the tip of the iceberg. HCO is also responsible on full life cycle, on upgrade, and on second day maintenance. So you can configure your KubeVirt deployment while the cluster is running. Okay, you may continue next one.
Thank you. So what we are planning for the next phases. First, we want to announce, no, it's not announcement yet. We are about to ship the community version of the Operator Hub very soon. It's around the corner, and it will be appear in the Operator Hub. I think it's very important news. About OLM integration. We are trying to be in sync with the OLM all the time, tracking the new features and so on. We are now working to implement the new operator condition feature, and later we are going to implement the scoped operator feature when it will be available from OLM. And also about the maturity of the product, we want to go to the next level of the operator capabilities. We are around level 4. We are working very hard on metrics and alerts, and we hope to move to level 5 and to get HCO to be a mature operator and support all the good things. About the configuration, we talked about it earlier. I want to talk about it a bit more. So as we said before, we want HCO to be the single point of configuration for the whole system. So we started with the node placement, and it's now supported, and you can define node selectors, affinity, and tolerations in the Hyperconverged custom resource, and HCO will propagate it to the other components. Next, we are in the middle of moving the feature gates from KubeVirt to the Hyperconverged custom resource. We are in the middle of this process, and later we want to retire the whole KubeVirt config map and to move everything to the Hyperconverged custom resource. And we are trying to use Open API version 3 in order to support the explain command and to have, as you saw in Oren demo, UI form for all the configuration fields. And we actually want to hear from you. How do you want to see the API? We want the API to be as easy to use as possible. We want it to have a common language and clear. And this is pretty much it. So let's I see that there are several questions in the chat, and I see that Oren already answering.
Yes, Sachin asks about OpenShift virtualization. OpenShift virtualization is the productized version of what you just seen. It's a product shipped by Red Hat. It's on a different source. It's in Red Hat operators source and not in community operators. The current version is 2.5.3. In upcoming month, we are releasing 2.6, which is supported in OpenShift 4.7. On the next version, we are aligning the versions, and it will be OpenShift virtualization 4.8 for OpenShift 4.8. And in the upstream, the latest version is 1.4.
Thank you.
Another questions? Thank you.
Thank you. Okay, so
that looks like all the questions.